Morning. Let's continue with our lesson on graphs. To state what is meant by work done. Work is force times distance. Both must be in the same direction. This is a vector, both a leaf of weight 13 kilonewton is connected by a cable to a motor as shown in figure. So the weight is 13 kilonewton. Okay. The leaf is pulled up a vertical shaft by the cable. A constant frictional force of 2 kilonewton acts on the leaf when it is moving. The variation with time t of the speed of the leaf is shown in figure 2.2. Okay. The extent of the leaf between t equals to 0 and 3 seconds. So this is 2.4. And over here is 3 seconds. So the acceleration is the gradient, 2.4 minus 0 over 3 minus 0. You get 0.8 meters per second square. 0.8. The work done by the motor to raise a leaf between the time t equals to 3 seconds and t equals to 6 seconds. So at t equals 3 seconds and t equals 6 seconds, the acceleration is 0, shown by the horizontal line of the graph where the gradient is 0. So in the leaf, there is a friction of 2 kilonewton. So the motor is pulling with a total of 15 kilonewton during the 3rd to the 6th seconds. Okay, so the work done is, you have to find the distance. So the distance traveled is 2.4 times 3 seconds, which is 7.2 meters. Work equals force times distance, which is, as I've said, 15,000 newtons times 7.2. $15,000 times 7.2, 108,000. Joules will be into two significant figures is 110,000 joules. A dolphin is swimming underwater at a constant speed of 4.5 meters per second. The dolphin emits a sound as it swims directly towards submerged driver. So this do not need to. The dolphin strikes the bottom of a floating ball so that the ball rises vertically upwards from the surface of the water, as illustrated in figure 2.1. The ball leaves the water surface with speed 5.6 meters per second, assuming air resistance is negligible. Calculate the maximum height reached by the ball above the surface of the water. So here you have the initial velocity as 5.6. Acceleration is minus 9.81 because you're moving upwards. The final velocity is 0 when it reaches maximum height and you're finding the height or the displacement. So the formula used is v square equals to u square plus 2as. So 0, 5.6 square minus 2 times 9.81 times S or H is equal to divide by 2 divided by 9.81. So into two significant figures, it is equals to 1.6 meters. The ball leaves the water at time t equals 0 and reaches its maximum height at t equals to t. On figure 2.2, sketch the graph to show the variation of the speed of the ball with time t equals 0, t equals t. Numerical values are not required. Over here, because air resistance is negligible, acceleration is constant. Therefore, it is a straight line graph. Straight line graph. Huh? The mass of the ball is 0.45 kilogram. Use your answer in B1 to calculate the change in gravitational potential energy of the ball rises from the surface of the water to its maximum height. So, GPE equals to MGH equals 0.45 times 9.81 times they ask you to use, the answer in, okay, it's 1.6. So the answer that you will obtain is 0.45 times 9.81 times 1.6. To two significant figures, it is 710 joules. State and explain the variation in the magnitude of the acceleration of the ball as it falls back towards the surface of the water if air resistance is not negligible. If air resistance is not negligible, that means there's air resistance. So the magnitude of the acceleration will decrease because of air resistance. Okay, that should be the answer. A small block is lifted vertically upwards by a toy aircraft as illustrated in figure 2.1. As the block is moving upwards, the spring breaks at time t equals 0. The block initially continues moving upwards and then falls and hits the ground at time t equals 0.9 seconds. The variation with time t of the velocity v of the block is shown in figure 2.2. So upwards as a max positive displacement. Air resistance is negligible. State the feature of the graph in figure 2 that shows the block has a constant acceleration. The graph is a straight line. Straight line means constant gradient. Constant gradient means constant acceleration. Use figure 2.2 to determine the height of the block above the ground when the string breaks at time t equals to 0. So you will have this negative displacement here will show the height of the block. The highest point here is when it is continuing moving upwards. So the question wants the height when the string breaks. So you have to take the area below the graph minus the area above the graph. So it's half times 0.7 times 6.86 minus half times 0.2 times 1.96 times 0.7 times 6.86 minus 0.5 times 0.2 times 1.96. Answer is 2.205. So the two significant figures would be 2.2. 2.2 meters. The block has a weight of 0.86 Newton. Calculate the difference in gravitational potential energy of the block between t equals 0 and t equals to 0.9. So it's mgh. So 0.86 is the weight, which is mg, times by the answer that we got just now, 2.2. Oops. Point 0.86 times 2.2. The two significant figures is 1.9 joules. On figure 2.3, sketch a line to show the variation of the distance moved by the block with time t from t equals 0 to t equals 0.2 seconds. Numerical value of the distance are not required. So it's 0.2 seconds. It is moving up. The speed is decreasing until it is 0. So the gradient must increase or decrease to a value 0. Okay. A block of greater mass is now released from the same height with the same upward velocity. Air resistance still negligible. Still explain the effect, if any, of the increased mass on the speed with which the block hits the ground. As air resistance is negligible, acceleration is still the same. Is constant, and of the increase of the speed, and the speed will be the same. Okay. Compatible table 1 point, complete table 1.1 by stating whether each of the quantities is a vector or scalar. Vector. Acceleration vector, power scalar, work is energy is also scalar. Determine the acceleration of the object from time t equals 0 to time t equals to 4 seconds. I think we'll end the... Okay. Something wrong with this. Okay. So t equals 0 to t equals 4 seconds. We have the gradient here. So the acceleration is the gradient. 253.35. 0.7. 4 seconds. 0.65 divided by 4. The two significant figures, or three significant figures for them. It is 0.163. Determine the distance moved by the object from t equals 0 to t equals to 4. So here you have to find the area below the graph. Half 0.735 times 4. Times. So it's 4.1. So the answer is 4.1 meters. Good enough. The motor represents that in figure 1.1 is caused by a resultant force acting on the object. On figure 1.2, sketch the variation f with time t equals 0 to t equals 12 seconds. Numerical values of f are not required. Okay. So you have a positive acceleration will give you a positive x force, and a negative acceleration here will give you force of negative value, but the gradient is larger, which will give you a magnitude of a larger force. Therefore, with a constant gradient is a constant acceleration. So from 0 to 4, constant gradient, constant force. From 4 to 7.6 seconds, zero gradient, zero force. Yeah, 0. And you might put in a larger force from here. Negative force. Okay. Explain in reference to forces acting on the stone, the shape of the curve in figure 2.1. We lost 2.1. Okay, I think that's it for now. Bye. I hope you liked the video. If you like the video, please subscribe so that you can get access to our notification for future videos on physics, CIE Cambridge. Bye for now.